Hello everyone, I'm Joe Kai-chen. Today I'm excited to present our research, which has been accepted by ECCV 2024, titled FreeCompose. Our research tackles several challenges related to image composition, utilizing prior or pre-trained diffusion models for object removal, image harmonization, and semantic composition. Our work begins from the task of image harmonization. In the past, much research in this area has concentrated on two major concerns. The first is a large amount of training consumption to gain a well-performed model. The second is the capability of model is limited to specific datasets. For example, a model trained on day-to-night dataset can hardly deal with harmonization problems about color gamut. So we wonder whether it is possible to take advantage of T2I prior and overcome this dilemma. We find that under the framework of DDS, which is an editing method, diffusion can locate the unharmonious places in an image, as depicted in the right graph, which is a visualization of difference between before and after one optimization step with copy-paste image as the input. Diffusion prior can find the pasted section and optimize them. But as an editing method, DDS itself cannot deal with harmonization well. As in the third comp, it will lead to damage to the object identity and the color of the background. To overcome such negative phenomena, we use a soft loss, which named as perceptual loss, to make a trade-off. As the fifth count displayed, we achieve a great balance between the change and the unchanged. Here are two specific results, as demonstrated in the magnified view. Using diffusion prior can also generate the effect of shadow along with harmonization. We wonder the potential of this method and then explore all other tasks under such framework. Considering the input background may be a scene with the original object and the object should be removed, we first come to the task of object removal. But as listed in the third count, DDS cannot tackle this problem. We think this is because DDS, like previous work, PMP and so on, mainly focusing on the semantic message. But object removal requires the change of structure message for good results. Therefore, we design a KV mask strategy. To be specific, we extract KV values from self-attention layers and use reshaped object mask to cover several values. So this way, message of original object will be removed and replaced by the phenomenon. Here are some results. Our method also addresses semantic composition, which is the task in paint by example and control count, and goes beyond traditional image harmonization. Unlike harmonization, semantic composition requires us to deal with regions of an image that either need to be impacted or covered, and the mask is uncertainty. So, instead of balancing loss, we implement a KV replacement design in self-attention layers. This enables the trade-off between identity preservation and overall consistency. The right graph is some results. Here is the overview of our pipeline. Under a unified framework, we utilize specific designs for object removal, harmonization, and semantic composition, and achieve good performance. Some other applications are also promising, including stylization and zero-shot multi-character customization, as shown below. Finally, let's take a look at the quantitative results. We tested the model on several metrics focusing on both object removal and composition tasks. The results clearly demonstrate a significant improvement. In conclusion, our research offers a novel and more effective approach to image harmonization and composition, addressing the major limitations of previous methods. We believe this work paves the way for future innovations in image manipulation, and computer vision. Thank you for your watching.